This is a target for the laser?
Yeah, this is the target. And the little circles are etched into the surface. We use these as identified positions so that we can spot sample on there, whether it's biomolecules or peptides or whatever.
Right.
We put them on and allow the solvent to evaporate, and then we stick them into the instrument. There's an automated probe that will accept the target from up here, takes it down into the area where the laser can hit it. The laser hits one of these spots, vaporizes what's there, and part of what's vaporized is also ionized. These ions are accelerated down the end of this thing where they're detected or else reflected back to another detector. And it's built sort of like a racetrack. They all start off at the same, with the same burst of energy.
Right.
But as they go through this long path, they separate on the basis of their differences in size, that is mass to charge ratio. And so by the end of this race, you have some ions getting there before the others, and the result is what's called a mass spectrum. It's sort of a fingerprint of the pieces that will allow you to figure out what you were analyzing. It's a very sensitive and useful technique.
And this basically tells you what the compound is.
Well, we're hoping. We applied it for decades to small molecules. Now we're applying it to big biomolecules. We're telling the good guys from the bad guys when it comes to things like bacteria and viruses and so on. You know,
By looking at their footprint.
Yeah. It's sort of like whole mouse analysis, where you put the mouse into the mass
into the blender and you.
Yeah. Well, it's not quite that good, but
whoops, it's a little loose in some
the
places.
one laser, the YAG laser, had so much power that we had to go to a prism instead of a mirror, because this is where the mirror used to be, and the laser was blowing holes in it. So with the prism, you don't have the same time of power being lost in blowing up the mirror surface that you did with the mirror. See, with a mirrored surface, you can only protect it for a certain spectrum of light. When you change the light, or you go beyond the intensity limits it can tolerate, it just burns a hole in it.
Wow, amazing.
So, definitely a cool toy.